everyone. I am Harni and my team members are Ritika and Subiksha. This project is carried out under the guidance of Mrs. Anjali Nivedita, Assistant Professor, Department of CSBS. Today I am presenting my project titled AI-based handwritten digit recognition integrated with CNN model. This project comes under the domain of machine learning and computer vision. The main aim of our project is to develop a system that can automatically recognize handwritten digits from 0 to 9. In real life, handwritten data is widely used in applications like bank checks, postal codes, and form processing. However, recognizing different handwriting styles manually is difficult and time consuming. So to solve this problem, we use artificial intelligence, specifically a convolutional neural network model, which can learn patterns from images and accurately classify digits. This project focuses on developing an AI-based system using convolutional neural network for recognizing handwritten digits. The model is trained using MINIS dataset, which contains thousands of labeled images of digits from 0 to 9. One of the key advantages of CNN is that it automatically extracts important features such as edges, curves, and shapes without the need for manual feature engineering. In our system, we have also integrated a web interface where users can upload handwritten digit images. The system performs pre-processing on the image and then predict the digits in real time. The model achieves high accuracy even when the input images are slightly noisy or of low quality. These are the base paper details of our project. Now coming to the problem identified, firstly we observed that recognizing handwritten digit is challenging due to variation in writing styles and differences in image quality. Traditional methods are not efficient enough to handle these variations, which creates a need for advanced AI-based solution. Secondly, there is a strong need to solve this problem because many real-world applications such as banking system and document digitization require accurate and automated digit recognition. Manual pre-processing is time-consuming and prone to errors. To address this issue, we developed a solution using a convolutional neural network model trained on MINIS dataset. This model is integrated with a web application, allowing users to upload images and get prediction instantly. This approach improves accuracy, reduces manual effort, and provides a scalable solution. To overcome the challenges in recognizing handwritten digit, we propose an AI-based system using a convolutional neural network or CNN model. In this system, the input is a handwritten digit image provided by the user. The CNN model processes this image through multiple layers. First, the convolutional layer extracts important features such as edges, curves, and pattern in the digit. Then the pooling layers reduce the dimensionality while preserving essential information. After feature extraction, the data is passed to fully connected layers where the classification is performed. Finally, the softmax layer predicts the probability of each digit from 0 to 9 and gives the final output. This approach eliminates the need for manual feature extraction and improve accuracy. The system is also integrated with a web interface allowing users to upload images and get prediction in real time. I am explaining the architecture of our project. First, the process starts by loading the required libraries such as TensorFlow, Keras, and NumPy, which are essential for building the model. Next, we construct the neural network in our project. We use a convolutional neural network where different layers like convolutional, pooling, and dense layers are defined. After constructing the model, we initialize the parameters such as weight, bias, learning rate, and other hyperparameter. Then comes the training phase where the model is trained using dataset. During this process, the model learns pattern from the input images. Once training is done, we calculate the accuracy using the validation dataset to evaluate the model performance. Next, we check whether the end condition is met. If the accuracy is not satisfactory, the model goes back to training and improve further. This loop continues until we achieve the desired performance. Finally, once the model reaches good accuracy, we move to the testing phase where the model is applied to new data for prediction. After successful testing, the process ends. Now I am explaining the model architecture used in our project. First, we start with the dataset which contain images of handwritten digits from 0 to 9. This dataset is divided into two parts, the training dataset and the testing dataset. The training dataset is given to the convolutional neural network where the model trains features such as edges, shapes and pattern of digit. In our project, we use a CNN model based on the architecture, which is known for its deep layers and strong feature extraction capability. After training, we obtain a trained CNN model. Next, the test dataset is provided to this trained model to evaluate its performance on unseen data. Finally, the model predicts the output as digit from 0 to 9 based on input image. Now I am explaining the ultimate finding of our project. First, our model achieved good accuracy in detection, meaning it can correctly recognize handwritten digits with high precision. Next, the system is able to identify key features from the input images such as edges, curves and shapes, which helps in accurate classification. We also observed increased prediction performance as the model improves over training and gives reliable result on new data. Finally, through proper validation and testing, we ensured that the model performs well not only on trained data but also on unseen test dataset. This finding shows that our model is effective and reliable for handwritten digit recognition. Now I am explaining the model details. First, we begin with the initial planning phase where we define the project objective and overall approach. Next is the research and data collection phase. In this stage, we gather the required dataset and study existing method related to handwritten digit recognition. Then comes the model development phase where we design and build our CNN model for classification. After that, in the prototype development phase, we create a working model and test its basic functionality. Next is the deployment and testing phase, where the model is applied and tested using real and unseen data to evaluate its performance. Finally, in the evaluation and optimization phase, we analyze the results and improve the model for better accuracy and efficiency. First, the hardware requirements. The system used is a Pentium i3 processor with 8 GB RAM, which is sufficient for model development and execution. A 500 GB hard disk is used for storing the dataset and project file. We use a 15-inch LED monitor for display along with input device like a keyboard and mouse. Next, the software requirement. The operating system used is Windows 10 Pro. The coding language used for implementation is Python version 3.10.9. We use Flask as the web framework to build the application interface. For the front end, we use HTML, CSS and JavaScript to design the user interface. These are the basic hardware and software requirements of our projects. This system has several real-world applications. In the banking sector, it can be used for check processing and automatic number recognition. In postal service, it helps in recognizing handwritten postal code for efficient sorting. In education and administration, it can be used for digitizing handwritten forms and records. It also supports large-scale data entry automation, reducing human effort and minimizing errors. Additionally, this project forms the foundation for advanced optical character recognition system, which can be extended to recognize not only digits but also characters and words. Overall, this system improves efficiency, accuracy, and scalability in handling handwritten data. Now, I will demonstrate the working of our handwritten digit recognition system. Here you can see the web-based interface of our application. In this section, we have also provided instruction to guide users on how to use the system. Users can upload handwritten digit images using the upload option. The system support image formats such as JPG, JPEG and PNG. For better accuracy, recommended to upload clear and properly written digits. The digit should be centered with good lighting and minimal noise. Unclear or blurred images may lead to incorrect prediction. Now, upload a handwritten digit image. Once the image is uploaded, the system performs pre-processing steps such as resizing the image to 28 by 28 pixel and normalizing the pixel value. After pre-processing, the image is passed to the trained CNN model. The model extracts important features like edges, curves, and shapes. As you can see, the system successfully predicts the digit as the output. The prediction is generated in real time with high accuracy. We can also test the system with different handwritten input to verify its consistency. This demonstrates that our system is efficient and accurate.